right, so the first part of this video about similar figures is actually going to go over the activity that we're going to work in class, or that we have already worked in class, just to make sure that you didn't miss out if you were absent on that part. So figures that are the same shape but not the same side are called similar figures. So not the same size and same shape, okay? So there were some directions. You were supposed to look at triangles that were on a separate sheet of paper and determine whether you thought they were similar or not to triangle A, B, and C. So when we look at triangle A, triangle RT and Y were similar to triangle A. The base of triangle A, the height of triangle A was 4 and the base was 8. The triangle of triangle R was 3 and 6. T was 2 and 4. And Y was 4.5 and 9. So how did I determine that they were similar? Well, I looked at the ratio between the base and the height. So if I look at the ratio between the base and the height, that's going to give me 2 over 1. If it's similar, then the ratio between the base and the height on the next one should be the same. So I'm doing base over height, base over height. On each of these, they all get a 2 over 1 ratio. On the next part, it was triangle Q, W, and S, and those values were 8, 10, 6, 7.5, 2, and 2.5. And again, I'm going to look at the ratio base to height, and I get 5 over 4, 10 over 8, which simplifies to 5 over 4, 7.5 over 6, which you may actually have to do the division to figure out that this is 1.25, which is the same as 5 over 4. And then the last one is 2.5 over 2, which again, you may actually have to do the division to figure out that this is 1.25, and you get 5 over 4. So when we describe the relationship between the base and the height of each triangle, the base, to triangle A, the base is twice the height. That's what you should have come up with. That's why the ratio was 2 to 1. See, the base was twice the height. If a triangle has a height of 15 centimeters and is similar to triangle A, determine its base. Well, again, the height was the smaller value. The base was 2 times that. So 15 times 2 would give me 30 centimeters. Describe the relationship between the base and the height of each triangle that is similar to triangle B. Well, it's 5 to 4. So what this actually is a scale factor. A scale factor is a number that can be multiplied by any part of one figure to get a part of the other. So, in other words, see how we got this 1.25? To get from here to here, you multiply by 1.25. So that means that the base is 1.25, or that's the same as 5/4, times the height. So if a triangle has a base of 25 centimeters and is similar to triangle B, to determine its height, we are going to multiply by 1.25. And that's actually going to give us 20 centimeters. Okay. So the next part is you were supposed to take these triangles and write on them what triangle it was similar to. So as we filled out on the chart, this was B and B and A, because this one was 2 times and this one was 1.25 times. Okay? This one was 1.25 times. Okay? This one would be B, A, and A. Right? So that was the first part of what we were doing today. And this is what we followed it up with, similar figures notes page. So when we look at this, again, similar figures have the same shape, but they may or may not be the same size. So this one says parallelogram ABCD is similar to W, X, Y, and Z. So first thing that you should notice is that this angle appears to be the same measurement as this angle. This angle is the same as this one. That will always be true. Corresponding angles and similar figures are congruent. So write the meaning of corresponding angles in your own words. One possible response may be that angles that are in the same position. That word same position is what we mean by corresponding. In similar figures, are the same size. Okay, same size? That's what we mean by congruent. So all I did was change out some of the math words for some regular words. So which angle corresponds to A? That would be angle W. Which angle corresponds to angle D? That would be angle Z. So now we need to talk about corresponding sides. Corresponding sides of similar figures are what we call proportional, and that's what we were looking at before, is the relationship between the sides. We set up a ratio, because if we could set up a ratio, then we can set up a proportion. So write the meaning of corresponding sides in your own words. One possible response would be, I can write ratios that compare the sides in the same location. Again, same location is talking about proportional. That's what that word, or sorry, it's talking about corresponding. That's what that word means. The ratios will be equivalent. And I use the word equivalent. You could also use equal. It just means same measure. So which side corresponds to CD? That would be YZ. Which side corresponds to BC? That would be XY. Okay? And we know that those should have a proportional relationship, which is actually going to lead us to our next part. In those figures, AD measured 11 and DC measured 14. So because these are similar figures, the ratio between their sides should be the same. So when I look at AD matching up with WZ, I don't know what WZ is, so I'm going to put an X there. But I do know that YZ is 21. So within these two, those ratios should be the same, which means if I've got two ratios that should be equal, I can set up a proportion. And that's what we mean by the sides being proportional. So we're going to look between and within to see if we can find those links. In this particular proportion, it's not very easy to get from either one. So at this point, I would recommend cross multiplying. 11 times 21 is 231. And 14 times x is 14x. So how do I solve that equation? To undo multiplication, I divide. So 231 divided by 14 gives me 16.5. Using that same similar figure, I'm comparing AD and WZ, which I don't know WZ. DC, I'm comparing to its corresponding side, YZ, because I can also go between those two figures. So I had AD compared to WZ, DC compared to YZ. Those ratios will still be the same, meaning I can cross multiply here, erase this, and 11 times 21 is 231. Notice it's the same thing that I did here. And 14 times x is 14x. Did you get the same thing as you got up here? Yes. So when I divide, I'm going to get that x is 16.5. Whichever way you set it up, you just need to keep the parts consistent. So let's talk about these. All right, which angle corresponds to BAC? Now, it tells you triangle ABC is similar to XYZ. The order of these letters is very important because it tells you A matches up with X, B matches up with Y. So what that means is that A, I'm going to put a little arc there, matches up with X. B, so I'm going to put 2 there just so that they look different, matches up with Y. And then C matches up with C. I'm going to put 3, just so I can see the difference between all those. So which angle corresponds, same position, to BAC? Now B, A, C. The letters here, it tells you what order to trace out your angle in. So really, we're talking about this angle here, which matches up with this angle here. So I can say Y, X, C. Okay. Which side corresponds to CY? Well, CY is right here, and that's of the smaller triangle. So CB is for the bigger one. Let's look at some other angles. CYX. So starting at C, go to Y, go to X. That's this guy right here, which means I'm looking at this one up top. That will be A, B, C. Okay? So the angle that you're actually looking at right here, that should always be in the center when you're listing the angle with 3 letters. Which side corresponds to BA? That's that long side over there. So that means it should be the long side over here, which is YX. Our second example has 2 similar figures. They're trapezoids this time. And we're looking for some corresponding pieces again. The first one says, what corresponds to angle S? Well, if I look up here, angle S is in the 3rd position, so it should be angle Y. And that should kind of make sense because this trapezoid has actually been flipped over. So S matches up with Y, R matches up with X, T with Z, Q with W. But look at these statements because sometimes that'll help you if you're confused about which one it should be. So what matches up with W? W is right here, so it should be Q. And again, Q is in the first one, W is in the first one. What side with WZ? QT. And again, I can see that here. WZ should be QT. Which side corresponds to ST? That should be YZ. All right, so the next part is we're going to write and solve a proportion to find the value of n by comparing adjacent lengths within the similar figures. So when I'm looking at my similar figures, I'm looking for n. So I'm going to set up a proportion within this figure. So that means I'm going to compare 6 to n. Which means I can go to my other figure, and I am going to compare with n as well. So I started with 6 and I went to n, which means I should start with 12 and move to 24. So I'm comparing the height to the base, the height to the base. Now luckily this one's kind of easy because we can look and say, okay, 6 to 12, that means I'm dividing by 2. 24 to n, divide by 2. So n is going to be 12 inches. Now we want to write and solve a proportion to go between the similar figures. Okay? So what that means is I want you to compare a piece of one figure with a piece of the other figure. So if I compare the height of this figure, I should do it to the height of this figure. So I'm doing 6 over 12. So if I went from figure 1 to figure 2, then I also need to go from figure 1 to figure 2. So that's going to be n over 24. Again, this one's pretty easy because I can go from here to here and multiply by 2, which means n is 12 inches. So again, I'm just proving to you that using proportions, as long as you're keeping things consistent, you're making sure you're comparing the same parts of a figure, there are many different proportions that you could actually use to solve for these values. So please complete the evaluate problems that are following in your practice book, and who's correct as well. It's a short activity that goes right after the homework, and we'll talk about it later.